All right, all right. Going on to the next problem here. Oh, that's not what I wanted. All right. Let's go to this one. It says determine the range of the function below. Again, I do want to apologize against some of these graphs we didn't cover. So, for example, this problem here, this is a quadratic function. We've never talked about this. Linears, yes, I will hold you accountable for linears. But these quadratics, I will change my grading a little bit because, again, we didn't talk about this in class, and it's not fair for you guys to be tested on it. I did not make the test, therefore, I had no control over what went into it. But again, I will take this into consideration when I'm doing your grading. So, nonetheless, we're going to talk about this briefly. So make sure you're taking good notes. Again, the key word here is range, right? So what is range? Well, range is a set of output, right? So range is the set of range, which is y, the set of outputs. Now, I know you're tempted to say, Gons, um, I still don't know the graph, so I shouldn't get this wrong or blah, blah, blah. But again, if you take the time to analyze what you're doing, it's not that difficult. Again, all this, even though it looks like a upside down U, right? A parabola, a quadratic, we still know what a range is. Range is a set of outputs. Now, again, this is nothing more than a whole bunch of points, but instead of a line, which you're familiar with, now they form like a upside down U. So nothing's changed, right? So again, if you look at these points, all of these are some x and some y. For example, this point here is -2, -7, right? Or -2 and 7.5. This point here is -3, -2, right? So when it comes to range, well, we're talking about the outputs. So when you look at these points, well, let me see. Is there a point where you have a y of -10? And the answer is yes. Look, we have this point, which is a -10, and we have this point, which also has a -10. What about a -8? Yeah, it actually has these 2 points, right? What about a -6? Yeah. What about a -5? Yes. What about a -3? Yes. If you keep going up, but what happens at 2? Notice how at 2, right, here, this point, which happens to be the highest point, when you project it onto the y-axis, is right here, right? So look at carefully what's going on, right? Range is a set of outputs, right? We're talking about the y coordinates. Look, if you go above 2, there's no more points above 2. So what does that mean about your outputs? Well, our outputs have to be less than 2. And why? Because look, if you go to a 1.5, right? Call it right there. There is 2 points that actually have a y of 1.5. Notice if you go to 1, we have 2 points that have a y value of 1. Again, we're strictly worried about the output. So the output is we project it onto the y-axis. And look, it is any point below 2. Because all of these y's that I'm going over with my red marker, notice it comes up. When y is -1, look, we have 2 points that have a y of -1. When -3, we have 2 y's that have a y of -3. So again, here, this is a special point. Make sure you mark it and you project it to the right. Make your solid dot here and project it down. So what is my range then? Well, my range is, I'll just write it out here. Y, because it is my range, it's the y, it's the output, is anything that is less than or equal to a +2. That is your range, right? Again, I know you're saying, well, gods, what about the x's? It doesn't matter what x's are. Because look, this problem wants us to find the range. So again, range is looking at the y coordinates of each point. So again, what y's are being used? It's the set of outputs, right? So look, here we're looking at all the points. We're looking at the y's of each point. So again, notice how this one had it at -10. Anything is being used, but something special happens here. This is the maximum point that is utilized. What is the y at this 2? Look, I'm sorry, what is the y at this point? It is 2. If it makes you feel any better, label this point. This point is negative 5, comma 2. Again, I apologize. Oh my goodness. I'm doing this in something completely different. There it is. So that is a point negative 5, 2. This is the highest y value. Everything else is below it. So your range, it's the y's, it's anything less than 2. All right, all right. Let's go to the next point here. Oh, sorry about that. Our next problem here. Let's do this one. The graph represents the height of the ball in feet as a function of elapsed time since the ball was hit. The golf ball was in the air for 4 seconds. All right, so that's very important information here. We have a graph comparing the height in feet as a function of time. Okay, so I'm comparing time to height, which is here. Time to height. Now I'm also given something important which says the ball was in the air for 4 seconds. So obviously here's my graph. Obviously it's going to start at 0, 0. Why? Because I start taking time at 0 and the ball's on the floor, which means I have a height of 0. So yeah, this is like the curvature of the ball, right? What happened? Oh, what's getting some height. At 2 seconds, it reached its maximum height at 80. Then it came back down and hit the floor after 4 seconds where it was at a height of 0 again, right? Question says, what is your domain and range? Keywords here. Again, domain and range. So, again, we're going to write down our key facts. Domain is X, set of inputs, range is Y, set of outputs. Now remember, this isn't so much, I mean, can we sit here and label all the points? Yes. But what you have to keep in mind is that we understand that this graph is a whole bunch of points. So remember, we're looking at what are used, right? What is the information that we're using, right? What are the inputs and the outputs? Now again, notice how this is a straight, or I'm sorry, not a straight line, but a continuous line, so we can actually draw inequalities. Going back to discrete versus continuous. So looking at here, well, let's look at our domain. Domain is the x's utilized, right? So again, I'm going to get here a little marker. Do we have a value of x is 0? Yeah, that's where it started. What about at 0.5? Yeah, look, it goes up right there. What about 1? Yes. What about 1.5? Yes. What about 1.75? Yeah. So what can you tell me about this? Well, it's any point from 0 all the way to 4. Well, why 4? Well, what happens at 4? The graph stops. The ball hit the ground already. Is the ball still in the air after 4 seconds? No, it already hit the floor, right? So what is your domain? Your domain, again, it's the set of inputs utilized. So here, anything from 0 to 4 was utilized. So my domain is x is between 0 and 4. Now, remember, why am I having equals to here, right? X is greater than 0, right? Obviously, because x went to the right, right? Because again, we're talking about the x's utilized, right? But look, did we use the number 0? Yeah, that's when we started taking time. So I have a solid dot here. What about 4? Did we use that point? Yes, that's when the ball hit the floor. It is a solid point. See, so notice how these 2 points is where it starts, this is where it ends, and my domain is everything that's used, which is everything from here to here, right? Again, you can leave those lines on your paper, but I'm just doing this to show you the other way now. So now let's look at our range. Range is a set of outputs. So let's look at the y coordinates now. Let's focus in on the y axis, right? Because this is what range is. It's a set of output. So what's happening here? Let me use a different marker. Well, does the ball use height of 50? Yeah, right. Look, actually happens twice, right here and right here. What about 40? Yeah, right. It's used. What about 30? Yeah. What about 20? Yes. What about 10? Yes. 0? Yeah. Look, this is actually where it's used. This is actually where I start. It is at a height of 0. So notice how here I used it. I actually had 2 points where the height was 0. What about 60? Yes. What about 70? Yes. What happens at 80? Uh-oh. There's actually only 1 point. What happens at 81? Well, the ball never reaches a height of 81. So if range is a set of outputs, do we use the number 81? No. What is the highest number that we use? 80. What is the smallest number that we use? 0. And notice how this graph is anything between 0 and 80, so my range is anything between 0 and 80. Now notice how, again, I'm putting open dots and closed dots because I use these points, right? 80 was the maximum that my ball got, so I got up to an 80. 0 is where I started, so that is what I'm going to use. So my range, or actually I'm going to write it in here, is 0 to 80. Now again, range is a set of outputs. I don't know how you had it on your test. You can have either the letter Y, and again, because 0 and 80 are part of the graph, notice how it's solid dots. I have this because my y is between any of these values. Now, could you also add f of x? And the answer is yes. Remember, f of x is nothing more than just y. So you actually could have had these two. You could add y or you could add f of x. Those are the same thing. We talked about this in class before. Let me just clear that up for you here. So again, this is f of x. F of x and y are the same thing. So actually write both of these down just so we can have it in writing. 0 is less than f of x, which is less than 80. Again, f of x is just a fancy way of writing y. It allows us to see a different name, which is actually going to guide us into the next problem. All right, so again, what I write on my paper, you should have. So make sure you have this written down, please, and also what's on the graph. All right. Let's go to the next one.